By definition, a black body is a perfect absorber and a perfect emitter. That means it absorbs all light that falls upon it, and it also emits all light. Now, if you have a solid, let me put it in an oven, at 1500 degrees, it starts glowing orangish reddish, and then it becomes a little more yellowish, and then more whitish at about 5500 degrees. At about 12,000 degrees, it starts appearing to be bluish in color. Black body radiation is a type of radiation that we're discussing right now. The black body radiates everything under this curve. So these are the curves for different temperature black bodies. A black body at 2500 degrees Kelvin, a black body at 3400 degrees Kelvin, a black body at 4400 degrees Kelvin, and a black body at 5500 degrees Kelvin. First of all, we notice that the curve of the 5500 degrees, the hotter black body, it engulfs all other curves. So all other curves are under this larger curve. And so another thing that we notice is that the peak of the curve, that's where the black body emits most of its energy. It appears to be moving to the left as the temperature is increased. Now left is the higher frequencies where we have ultraviolet, X-rays, and gamma rays. So as the temperature of the black body is increased, more and more high energy photons are released. When we look at the temperature of the sun as an example, this curve represents how the sun releases its energy. We see that most of its energy is in the green and yellow photon region. So most of its energy is coming in this region here. A black body at 4400 degrees, it gives most of its energy in the red. A black body at 3400 degree temperature, it gives most of its energy in the infrared part of the spectrum. A 2500 degree black body releases most of its energy in the infrared. So this object, because it releases some visible photons here, it's going to appear to be red. This object appears to be more orangish, reddish. This one here also appears to be more orangish, reddish, but it's giving you a lot of yellow and green and blue, so it's going to appear to be more and more lightish yellow. At 5500 degrees, it's going to appear to be more whitish yellow. The peak of the black body determines the temperature of the object as well. So if you look at the spectrum of a star, and we can see where most of the energy is emitted, we can determine the temperature of the black body. Stars are good examples of black bodies. Even though they're not solids, they're gaseous, they're big balls of gas, they are so dense that there are very good approximations of black bodies. Now, black bodies give you this continuous spectrum, so the sun gives you all wavelengths, everything from X-rays all the way to radio waves. So stars of different colors, they appear to be different temperatures. When we look at the stars, the hottest stars appear to be bluish in color, then whitish in color, then yellowish, then orangish, and then reddish in color. Those are all the colors of the stars that we have in nature.